Hi, welcome to my video on the greatest common factor. The greatest common factor, G, C, F. First letters in each word, and is denoted G, C, F, normally written together. The greatest common factor of two or more natural numbers is the greatest natural number that is a factor of each. Let's explain that. Let's go on further. Factors of a number can be found by using any combination of 1 in the number, divisibility rules for 2, 3, 5, 9, 10, and a single repeated digit, factors of a factor, or prime numbers, which we practiced that earlier when we found factors. To find the greatest common factor of two or more numbers, 4 methods can be used. And I want to stress the GCF is extremely important in doing the math in grade 10, 9, 11, 12, calculus. It's very important to learn how to handle it. Find the GCF. Method 1. List the factors of each number. Steps. We list the factors of each number. Select the largest factor which is common to all the numbers. And when we have that largest factor, we have the GCF. Find the GCF by listing all the factors of each number. 8 is even, so the factors are 1 and 8. Also, 8 is even, so it's 2. 2 and 8 goes 4. So there's the factors of 8. The 20 is 1 times 20, which is the first pair. Is even, so it's a 2. 20 divided by 2 is 10. Or we could have had a 0, and because it ends in 0, 10 is 20 is divisible by 10, or 10 is a factor. 10 also, because it ends in a 0, we have a 5 as a factor. 20 divided by 5 is 4. 4 has a factor of 2 already done. So look at all these factors. What's the largest one that we have here? 8, no. 4. 4 is the GCF. So the GCF is 4. List the factors of 6. Again, start with 1 and 6. Because it's even, it's 2 times 3. Factors of 15 are 1 times 15. And because it adds up to 6, multiple of 3, 3 is a factor, so it's 3 times 2. 21, 1 times 21. And again, the digits of 2 and 1 add up to 3, so it's divisible by 3. 3 is a factor. 3 times 21 divided by 3 is 7. Notice all these factors are primes, so therefore the GCF is the largest one. 6, nope, 6 is not over here. 2 is here and here, but it's not in 21. 3 is in 6, 3 is in 15, 3 is in 21, so the GCF is 3. Practice, pause, work these out, and then start up the video. Factors of 9, 1 times 9, and is a 3 times 3. 45 is 1 times 45. 45 has a 5 at the end, so 5 is a factor. 5 times 9. Notice that a factor of 9 is also a factor of 45, so 3 is a factor of 9. 3 into 45 goes 15. Or, if another way to get 9 is add 4 and 5 up to get 9. A multiple of 9, 9 is a factor. But I look at 9, I'll get a 3. And that's how come I can tell I can use a 3. Doing 10 is 1 times 10. And 10 is even, so it's 2 times 5. 14 is 1 and 14. 14 is even, so it's 2 times 7. 22 is 1 times 22. Because it's even, it's 2 times 11. Double digits divide by 2. Repeated digits, or is even, same thing. You get 11. And, oops, I forgot to go back to here. My mistake. I just kept going. The factors that are 9 Yes, 9 is here and 9 is here. That's the greatest common factor. I have a 3, but 3 is not big. 3 is smaller. 9 is the GCF. Let's go back to number 2, GCF. Let's look at the smallest number. 10 is not in these. 5 is not in these. You notice that these do not end in a 0 or a 5, so 5 can't fit. 2 is in 10. 2 is in 14. 2 is in 22. So 2 is your GCF. And let's do number 3, 4 and 7. 4 is 1 times 4. And because it's even, 2 is a factor. 2 times 2 makes 4. 7 is 7 times 1. Notice that 7 is the prime number. Notice that, let's look at these two. 7 is not in 4, but 1 is your GCF. Now, normally, you don't look for 1. 1 is always a factor of every number we talk about. So I just want to throw this one in extra. So that's listing the factors of each number and picking the largest one out. The second method to find a GCF, I call it the ladder. And here we find a factor common to each number. Divide each number by the common factor. And we keep going. And it says divide again if there's another common factor in the resulting numbers. When you divide again, if there's another factor common, you keep going. And when you have no more common factors, you multiply the factors on the left side. There you go down. Here we go. Pick a factor that's common to each. Well, if you look at 6, 6 is not in 15, but we have a 6 is even, but 15 is not. So we have a 3. Notice that 3 is in 6 and 3 is in 15. So 3 divided into 6 goes 2. And 3 goes into 15, 5. Now you notice that 2 and 5 are primes. They do not have any common factors, only 1. So the GCF is 3. And we have 3 this time. Underline them. What number goes into all these? Well, if you eyeball it, we look at 8. 8 is not in 12. Nope. We could take a 2, since they're all even. Let's go with a 2. 8 divided by 2, or 2 divided into 8 is 4. 2 divided into 12 is 6. 2 divided into 28 is 14. Now if we look at 4, 6, and 14, notice they're all even. We can divide by 2 again. These are the resulting numbers. So let's divide by 2. We get a 2. 2 into 6 is 3. 2 into 14 is 7. Notice 2, 3, and 7 are all prime, so we only have the GCF is, we have a 2 and a 2. That makes it 2 times 2, which is 4. 4 is the greatest common factor of 8, 12, and 28. Again, practice, pause, work them out, and then come back to see if you're right. Okay, here we go. What number will divide into all these? Again, they're even. You always look for the even number first. That's what I do anyway. If 2 is not there, I look for a 3. 3 is not there, I look for a 5. I look for prime numbers, actually. 2 into 12 goes 6. 2 into 18 goes 9. 2 into 24 goes 12. 6 is even, but 9 is not. What other number? 9 has a 3 times 3. 6 got a 3. Oh, so 3 is in all of these. 3 into 6 goes 2. 3 into 9 goes 3. 3 into 12 goes 4. And notice there's no factors common because one of these is prime. So the GCF is, multiply the numbers down the left-hand side. 2 times 3. And 2 times 3 makes 6. So 6 is the greatest common factor to 12, 18, and 24. Again, we have a 2. Most times you see a 2, 3, a 5, a 7 common. So 2 into 16 is 8. 2 into 40 is 20. 2 into 58, 56 is 28. They're even, so we go again. 2 into 8 goes 4. 2 into 20 goes 10. 2 into 28 goes 14. Again, they're all even, so divide 2 again. So that's 2, 5, and 7 when you divide each by 2. Again, 2 is prime, 5, no more common. So the GCF is multiply 2 times 2 times 2. And that gives us, that's the left side. Take those numbers, that gives us 8. So 8 is the greatest common factor in these 16, 40, and 56. Notice like repeating with a 2, there are times when we could have a 3 common. We could have a, let's go with a 3. Let's see. Is there a 3 in here? It adds up to be 6, a multiple of 3. Adds up to be 9, a multiple of 3. Adds up to be 9, a multiple of 3. Let's start with 3 this time, even though I could start with a 2. 24 divided by 3 is 8. 36 divided by 3 is 12. 3 into 72 is 224. Notice this time in 8, oh, they're all even, so we divide by 2. 4, 2 and 24 is 12, dividing by 2. Again, they're all even, so we divide by 2. 2 and a 4, 2. 2 and a 6 is 3. 2 and a 12 is 6. No more commons, so we have this time the GCF is 3 times 2 times 2. 3 times 2 is 6, times 2 is 12. So 12 is the greatest common factor in 24, 36, and 72. We have 5 and 11. 5 and 11. 5 is not in 11, so we have no common factor. Only the greatest common factor of this one is 1. So that's how we work out the ladder form. I apologize, I'm having 2 here a lot, but you see 3s, 2s, 5s, 7s, and so on. But let's go on with another method. And this method, which is important to learn, we practice the prime factorization. And the prime factorization, find the prime factorization of each number. When you do, you select the common factors. Then you select the smallest exponent of each factor. And you simplify, and you'll have your GCF. To explain steps 2 and 3, I did a little bit of explanation beforehand. Let's look at these examples. Notice that 3 is right here, and this is the 3 also. So 3 is the common factor between these two. And that's a 1, and that's a 1, because 1 is the smallest exponent. So 3 is your common factor here. In B, I have 2 cubed and 2 squared. 2 is common as your common factor. And the smallest exponent between 3 and 2 is 2. So you pick the common factor and you take the smallest exponent. And that gives me a 4. Now I have a lot of them here. I look and I see 2 is common. Yep. I see 3 here, but not over here. I see a 5 here, but not, and 5 is here and here, so we write down. Notice I'm writing down the multiplication. 2 and 5 are here. The smallest exponent of 2, remember that's 2 to the 1, so that's a 1, understood. 5 got 5 cubed and 5 to the 4th, so the smallest one is 3. So your GCF is 5 cubed is 125 times 2, if you had to do the GCF, or you had to get your common factor, then you get 250 would have been. But I wanted to illustrate picking out the factors that are common and the smallest exponent. Remember, when you think about the smallest exponent in 2 cubed and 2 squared, notice 2 cubed is 2 squared times 2. So the 2 in 3, 2, the 2 that's in, the 2 squared is in 2 cubed, and the 2 squared is here. That's why the smallest exponent is common, because the bigger exponent has the smaller one in it. Let's work out the prime factorization of these following this method. Here we go. Prime 9 is 3 times 3, so that's 3 squared. 21 is 3 times 7, so that's Can't go any further. So we have, what factor is common? 3. The smallest exponent is 1. So the GCF of 9 and 21 is 3. Greatest common factor. 12 is 2 times 6, and 6 is 2 times 3. 18 is 2 times 9. 9 is 3 times 3. So the exponential form prime factorization is 2 times 3. That's the factors that are here, and it's 2 squared. So notice you got 2 squared and a 3. In 18, we have a 2 times a 3, but we have 1 2 and 2 3s. So there's the prime factorization. Let's look, and we have what? A 2 common and a 3 is common. And the smallest exponent of 2 is 1. The smallest is a 1 for 3 and a 1 for 2. So in 2 squared and 2 to the 1, 1 is common. In 3 to the 1, 3 to the 2, 1 is common. So your GCF is 2 times 3, which is 6. So the greatest common factor is 6. 40. I have 4 times 10 as factors. 4 is 2 times 2. 10 is 2 times 5. So the prime factorization is 2, 3 times cubed, and a 5. 60 is 6 times 10. 6 is 2 times 3. 10 is 2 times 5. So we have a 2 and a 3 and a 5. And there's 2 2's here, so there's 2 squared. Right. Now, what's common? There's a 2 in each of these. There's a 5 in both of them, but there's no 3. So 2 and 5 is common. The smallest power of 2 is 2. Smallest power of 5 is 1. So that gives us 4 times 5. 2 squared is 4. 4 times 5 is 20. 20 is the greatest common factor of 40. Notice 20 divides into 40 twice. 20 divides into 63 times. Let's go with 3 of them this time. Notice the prime factorization is a little bit longer because you got to write up the primes. So it's good to know how to do it, but it's really a little bit longer. But you're using more fundamentals. 16 is 4 times 4, which is 2 times 2. That 4 is 2 times 2. So that's 2 is the factor, and it's 4 times. 40 is 5 times 8. 8 is 2 times 4. And 4 is 2 times 2. So the prime factorization, 2 is a factor, 5 is a factor, 1, 2, 3, 3 2's. 56 is 7 times 8. Or I could have gone with a 2 and then worked it all the way down, but if I see 7 8's, I get there faster. 8 is 2 times 4, and 4 is 2 times 2. So 56 is 2 is common, 2 is there, 7 is there, and there's 3 2's, so it's 2 cubed and 1 7. So what's the GCF right here? Well, we got the prime factorization of each of these done. So what factor is common? 2 is in each of them, okay? And the smallest exponent is 4, 3, 3. Smallest exponent is 3. 5 is in 40, but not in the other two. 7 is in 56, but not in the other two. So the greatest common factor here is 8. And pause, practice these. Ready? 10, 2 times 5. So the prime factorization is no change. 15 is 3 and a 5. So the prime factorization is 3 times 5. Oops. What factor is in both of these? We can see it as a 5. 5 to 1. 27, 36, 45. 27 is 3 times 9. 9 is 3 times 3. 36, 6 times 6. 6 is 2 and a 3. 6 is a 2 and a 3. And notice I forgot that, let's go back and do the prime factorization. I have 3, 1, 2, 3. 3 cubed, 27, right? And right here I have a 2 and a 3 that's common, or not common, but I have to write them down. So 2 and 3 got to be written down because that's the factors. There's 2 2s, is a square. 2 3s, so that's a square. And 49 is 5 times 9. 9 is 3 times 3. The prime factorization is this. I got to write down a 3 and a 5 because they're the factors. I got 2 3s, so 3 squared, and a 5. The GCF of these is what numbers in all these, what factor. Well, there's only a 3 here, so we have to check. 3 is here. Yep, 3 is in all of them. I don't have to. This is the one I got 1 factor, so if 3 is not there, 1 will be the GCF. And the smallest exponent of 3 is a 2. 2, 2, 2. You take the smallest one. So the GCF is 9. 36, let's try this one. 36 and 24. 36 is 4 times 9, which is 2 times 2. 9 is 3 times 3. Prime factorization is a 2 and a 3. So we get 2 squared, 3 squared. 24 is 4 times 6. 4 is 2 times 2. 6 is 2 times 3. I have a 2 and a 3 as factors. There's 1, 2, 3 2s, so it's 2 cubed, and 1 3. And the GCF is what factors are in both of these. A 2 is there, and a 3 is there, and the smallest exponent of 2 is 2. The smallest exponent of 3 is the 1, or just 3. 4 times 3 is 12. 12 is the GCF of 36 and 24. Greatest common factor. I have a little note here. The greatest common factor, we're picking out the greatest. But ironically, look, we're selecting the smallest exponent because the smallest exponent is in the big one. Opposite. Greatest, smallest. The fourth method, and this one is pretty fast. This is probably the fastest method of all of them, is factors of the smallest number. Factors of the smallest number. This is a quick way to do it. Select the smallest number. List the factor pairs of the smallest number. Select the largest factor from the factor pairs, which is common to the other factors, and you have your GCF. So, select the smallest number, find its factors, and check to see which one is in the other ones. And that's a fast way of doing it. Let's try. GCF by factors of the smallest number. Here we go. 4. Smallest number is 4. So we check the factors of 4. We got 1 times 4, 2 times 2. So is 4, if you check 4, and 4 is the number, is 4 in 8? Yes. 4 is in the 44? Yes. So the GCF is 4. I didn't have to go to 2 times 2. I always check the smallest number, and I check that number right away. So if that number is there, then I don't have to do any work. When I look at 15 and 5, the smallest number is 5. So is 5 in 15? 5 is a factor of 15, so therefore the GCF is 5. Because 5 is 1 times 5. So if you check the smallest number, a factor of the other one, it's quicker. I like this method, but I use it all my life. Let's try 14, 22, and 10. What's the smallest number? Smallest number is 10. So the factors of 10 are 1 and 10, and 2 times 5 because it's even, or it ends in 0, it's got to be a 5. But again, check. Is 10 a factor of the other two? No zeros. So then we check the next largest. We check a 5. Is a 5 in 22 and 14? No. So 5. Try 2. Oh yes, 2 is there because they're all even. So 2 into 22 goes 11. 2 into 14 goes 7. So the GCF is 2. D, 6, 21, and 60. The smallest number is 6. Factors of 6. Well, let's check to see if 6 will not go into 21. It will go 3 and 3 over 6 are 3.5. 3 goes into 6, or 6 goes into 60, but it got to go into all of them. So 6 is not it. So 1 times 6, I know 6 now. Now the factors of 6 is 2 and 3. The next biggest factor for 6 is 3. Will 3 go into 21? Yes, 7 times. Will 3 go into 60? 20 times. So the GCF is 3. That's the largest factor. I like this. This is I find it faster, quick, because when you're writing tests and when you're trying to think, factors of the smallest number works fast. Smallest number in 25, 50, and 35 is 25. Is 25 a factor of 50? Yes. But is 25 a factor of 35? No. So now we can't look at 1 and 25. We can write it down. But the factors of 25 are also 5 times 5. So we have to check a 5. 5 into 50? Yes, 10 times. 5 into 35? Yes. Notice all these numbers ends in a 0 and a 5. So 5 is definitely a factor. So the GCF is 5. 12, 30, 42, the smallest number is 12. So, is 12 in 30? 12 is not a factor of 30. Nope. So 1 times 12. So I have even, so it's 2 times 6. And 6 has a 3, so 3 into 12 is 4. They're all the factors. But as you list them, if you check them, but you got to be careful. Make sure you find the highest. 6 is the next largest in 12. 6 into 30 goes 5 times. 6 into 42 goes 7. So the GCF is 6. Again, 12 is not. Check the next largest. 4 is not. 3 could work, but 3 is not the largest. The GCF. 33, 22, 44. The smallest number is 22. 22. Now, 22 is not a factor of 33 and 44. So 1 times 22, 22 is not going to work. It's even, so it's 2 times 11. Notice that repeated decimal, single decimal, 3 is repeated, 2 is repeated, 4 is repeated. So notice that this one right here is 3 times 11. That one is 2 times 11. That one is 4 times 11. So if 22 is not going to work, check 11. 11 will go into all of these. So 11 is the GCF. And number 4, 14, 28, 49. 14. Is 14 a factor of 28? Yes, 4 goes twice. But 14 won't go into 49. So let's check what? 2 is even, so it's 2 times 7. Next largest is 7. Will 7 divide into 48 4 times? Will 7 go into 49 7 times? So the GCF is 7. 7 is the greatest common factor. I like this method. You should practice the other ones too, but this is the quickest one. Now, the fastest method of finding the GCF of 2 or more numbers, I say it's the factors of the smallest number. The latter method is the next fastest, because when you prime method, it takes a long time to do all the factors, write down the prime, and then check out the common factors and the smallest exponent. The prime factorization has more fundamental math. It will be used to find the least common multiple of 2 or more numbers in the next video, because we're going to do the least common multiple next. So let's do some more practice. Pause. Work these out. It's your choice. So I'm going to work the factors of the smallest number. So 9 is 3 times 3. Do I have to do that? No. If I check the factors of the smallest number is 9. Is 9 and 12? No. So 1 times 9 don't work. So 3 is a factor of 12. So the GCF is 3. I'm going to check. I'm using the factors of the smallest number. If I break them all down, then I'm going to do the prime factorization, or I can do the latter if I want. Smallest number is 6. Is 6 a factor of 18? Yes, 3 times. Is 6 a factor of 30? Yes. So the GCF is 6 without ever writing anything. Always check the smallest number and look at that number as a factor of the others. If that don't work, then break it down. Number 3, the smallest number here is 10. is 10 a factor? No. So 1 times 10 is done. So now I got a 2 times a 5 with the 10. 10 is smallest. 5 is the next largest. 15 divided by 5, 3. 5 is a factor. So the GCF is 5. As you can see, again, you got 5s and zeros, so it's 5. Smallest number, number 4. Smallest number right here is 8. Is 8 a factor of 16? Yes, twice. Is 8 a factor of 28? No. So 8 doesn't work. I'm going to try 8 is even, so it's 2 times 4. Next largest is 4. 4 into 16 goes 4. 4 into 28 goes 7. So the GCF of these three numbers is 4. 4 is the largest factor that will divide into 8, 16, and 28. Hope you enjoyed the video. Again, the greatest common factor. Very important. If you like my video, click on my like button, subscribe button, the notification bell, and write a comment on my video if you wish. Also, you can visit my website at www.mathfullyexplained.com. Find information about me, which is my degrees and teaching experience, and the teaching strategies used in my videos. And also you find the content on the channel, on the website, which will have the topics, the number of videos of each topic. The topics completed will be in black font. The topics to be completed will be in red font. Thank you very much. See you later. Bye.